Hey, good afternoon, everyone. We are seeing people join, which is fabulous. We're going to give just a couple minutes for people to hop in as I'm seeing this list quickly get longer. I see a lot of familiar names and some new ones. It's great to see you all joining today, and I appreciate you taking some time out of the middle of your week to hear us talk about Splunk Cloud. We will have Q&A open for any questions that you want to ask during the talk, and Meredith will help me collect those. And we'll make sure that we get that information over to me so that we can answer any questions that you might have. Meredith, just to make sure, can we hear you okay?
Yes, I believe you should be able to.
Perfect, thank you. We will just give it another minute and then we will fire away so that we can get everyone going and on with the stuff you came here for. It's definitely a beautiful day here in Cleveland, especially compared to some of the days we've had this weekend where it was raining and all that. So got a chance yesterday to go out and actually cut the grass, which was great because it confirmed that I'm still allergic to grass. It's always important to test a hypothesis. So you just got to make sure that things are still always the way that they appear to be. People just hopping in the webinar are like, what the heck is going on here? We have to make it fun here. It's been about an additional minute, so I think we're probably good with kicking that off. Meredith, if you want to start, and then we'll go into the content with everyone.
Yeah, of course. I'll go ahead and kick things off. So good afternoon, good morning, good evening, everyone. Welcome to our webinar for this month, May, for Splunk Cloud storage options. Your host will be Tom Kupchak, who will be reviewing the material and talking us through some wonderful different options for Splunk Cloud storage. I will be here to moderate. If you have any questions throughout, please do not hesitate to use the Q&A button, which should be bottom center. And for that, we will queue up all the questions at the end. I will also throw up polls, so feel free to ask any questions. If we need to put up an additional poll, we'll be happy to do so. And I'll pass it off to Tom.
Yeah, thank you so much, Meredith. And as Meredith mentioned, polls, we're going to actually start with one that's going to kind of tie into what we are looking for from you and who you are. So obviously, the audience here is going to be primarily talking about Splunk Cloud. So I realize that not everyone here is necessarily going to have Splunk Cloud. A lot of you hopefully do, but you might be considering Splunk Cloud, or you might be looking for potentially see if Splunk Cloud is something that's a good fit for you, or just curious about how this works, or you might just be here because you want to hear me talk for some reason. So I don't know why, but Meredith, let's fire off that poll so we can get that started. And like some of the, I would ask, just go ahead and answer. That's actually not that poll. The other one for cloud intro. Let's fire that one off. And I'm curious just to see how you are currently using Splunk Cloud. So there's a number of people that this could benefit. Whether you are an existing Splunk Cloud customer, you have a Splunk Cloud environment, you're using it, you want to learn more about how to leverage storage in there. You might be a client that is already someone that has Splunk, but you're considering migrating to Splunk Cloud. And you're using Splunk Enterprise on-prem, you've heard about Splunk Cloud, your salespeople have told you all about Splunk Cloud. You're like, great, we want to consider what this is like. Let's hear it from someone who works with this on a daily basis. What happens? If so, great. I'm here to answer questions that you have about storage and anything else around that line. There might be clients that are considering purchasing Splunk Cloud. You might not have Splunk at all, but Splunk Cloud is the solution that you're maybe looking for SIM. If so, this can give you an idea of what to expect. And finally, you might just be here because you find our webinars informative, entertaining, regardless of content. I hate to disappoint you that this webinar is just merely me talking. Last quarter's webinar, we had about 6 people who were way more interesting than me. So for those of you that stuck around and came back just for this, I appreciate it. I am looking at the poll, and basically everyone is either here for the Tom jokes or they're an existing Splunk Cloud client, which is kind of interesting to see. But most of you have Splunk Cloud, but more than half of you are here for the jokes, which I guess is good. So I'm going to try to make this entertaining, but we're hoping that everyone's going to have the opportunity to learn something as it goes on. So thank you all for joining and for sticking through and getting a chance to experience this. And we're going to hopefully make it entertaining and informative. So I want to start with like a really quick intro into storage, which obviously should be pretty obvious to everyone here, but I want to level set to make sure we're all on the same page. Why is storage important? Why is it something we need to care about? Why am I standing here in front of you blabbering about Splunk Cloud and storage? And why is that something that we are covering today? Well, a couple of big reasons. One of the big reasons that clients look for having storage is meeting retention requirements. One of our earlier webinars last year, we talked about compliance and how compliance is supported by Splunk and how often you're required to keep data in Splunk for a certain period of time in order to meet a compliance requirement. Now, some of those requirements could say, hey, I need to keep data for 30 days, 90 days, 60 days, a year, 7 years, whatever that might be. You might potentially have a compliance requirement that says, I need to keep this data around for a certain period of time. And in order to do that, you need to have storage to support that. So meeting retention requirements, making sure you have the disk space or the capability to store or restore that data is something that you often need to do. And that's one of the biggest drivers we see with clients for having data in Splunk and having different storage options to make that data available. That said, beyond compliance, what other things can we do? As a security service provider, we are involved with a lot of investigations for our customers and ensuring that data is stored in Splunk properly and available if there is something that's needed to be done for an investigation. So like when you need data, you will have it in Splunk and you will be searching it, and our SOC will be working through getting that data available. So supporting investigations, having that data available, you need to make sure that data is there. Having the disk space to do it is key. This becomes particularly important when you think about the timeline for discovering and investigating a breach. All too often, we hear about you don't discover an issue in an environment or you're not informed about it until many, many months after it happens. And if that data is no longer available in Splunk and you have to restore it, it can be something that takes a lot longer to investigate. Or if it's not even something that you've stored anymore, you might not have that convenience of having it in Splunk available. So making that data available for when you need it is important. And then historical reporting. You might have business processes or requirements that make you go back a certain amount of time in order to have a regularly scheduled report. I know we have clients that'll often run reports over a monthly basis or potentially even a yearly basis in order to get information for certain business processes. And having that data in Splunk available to drive those business processes and support what you need, that's something you need to have the disk space to back that up. So simplified explanation, obviously something that most of you are familiar with, but I want to make sure we're all on the same page. So now that we know that we need storage, let's talk about how we size that storage and what some considerations come into for that. So how do you size your storage? There are 3 steps I want to look for this. First, you want to determine what your typical search needs are. So what this means is how often am I running searches? What periods of time are we typically looking at? What sorts of things do we go into Splunk for? So this could vary by team and organization and group. And a lot of times you'll notice a clear pattern. Like, for example, different teams like developers or your help desk are commonly only searching over a very short period of time. Like an account lockout, for example, that might be something you only need the last half hour or hour of data to investigate. A lot of security alerts, you might be even looking back no more than a day initially to start that investigation. But depending on something, you might end up looking back a little bit further. But regardless, try to determine what your typical search needs are in order to make sure that that stuff is available in Splunk to be available. Next, you want to look beyond your typical and look at more recurring business cases, situations where you might need longer running searches and things that are commonly used in your Splunk environment, but maybe not something that's top of mind and on everything that's done on a daily basis. So like if there's a regular report that runs that we talked about, something you need for compliance, something you need for a business process, make sure you account for those sorts of things because you got to make sure that Splunk is able to do what you need. And then last, my recommendation, you take those two different parts, your typical search needs and your long running search uses, and then you combine those together and you size your storage to cover that. So you're thinking about this. I have Splunk. I want to figure out what my search looks like. How do I do that? Well, you can use Splunk to do that. So this is a search that we have that will help identify your typical search behavior. And what it does is it breaks things down into chunks. So you can see what the typical look back is for how far you're searching data. So for example, when I ran this search in the Splunk environment, you can see that more than half of the searches, but just a bit over half of the searches, were actually looking back less than 1 day. So these are your searches that run 15 minutes, the last half hour, last hour, up to the last 24 hours. So you can see in this environment, more than half of the searches are there. But the other thing you look at here is the next highest percentage are searches that are over 90 days. That's basically a full third of the searches in this environment were more than 90 days. And what this is telling me is there's two possible things. There's either a lot of processes that are running overall time and needing a lot of data, or there could potentially be areas of improvement where maybe there's a lot of searches that are just set to all time. You're running the search over an entire index, and what is going on? Why are we looking at all this data? Do we need to be doing that? So you run the search in your environment, you can get a lot of information about how people are using Splunk and potentially identify what are these use cases for doing that. And like if I'm looking at sizing storage and I see, oh, there's a ton of searches that are running over 90 days, I want to know the why so that I can identify how I can deal with this when I'm looking at picking out the best storage option. So that's a high level approach to doing that, but it gives a really nice snapshot of what's going on in your environment, where you should start looking into things. So now that you know you need storage and you have an idea of how long of a search period you need, let's talk a little bit about the options for storage in Splunk Cloud. So Splunk Cloud actually has 3 different storage options. The first option for storage is something that's called Dynamic Data Archive Searchable. I typically will just call this searchable storage, but DDAS is the acronym Dynamic Data Active Searchable. Marketing terms aside, searchable storage is going to be what's the most straightforward way to refer to that. Like the name says, that's the data you can search in Splunk. The second one and the third one are also going to be archive options. So it's going to be data that's not actively searchable in Splunk Cloud without doing something, or not actively searchable at all in the case of the next one. But Dynamic Data Active Archive, that's a Splunk managed archive where that data can be restored to Splunk Cloud, but it's not searchable all the time. And finally, DDSS, Dynamic Data Self-Storage, that's where you archive data to a third-party location in an Amazon S3 bucket. And that's something that's not searchable in Splunk Cloud. It's a low-cost option, but it makes that data a little bit more difficult to get to. Let's talk about each of these in a little bit more detail, though. So with Dynamic Data Active Searchable, DDASS, your searchable data storage, that's the data that is searchable in Splunk. You type a search in the search box, you hit enter, those are the results that come back. That is set to be searchable for your full retention period. So whatever you have configured in that index to be searchable in Splunk Cloud, you'll get those results back. This is going to be the best choice for data that you want to be able to use in Splunk Cloud. You want to leverage the normal search interface. So like searching data in Splunk, you use DDAS for that, and that becomes available using that normal interface. So that's going to be your best option for making that data available. The trade-off here is that it is the most expensive option, because that is data that you're paying basically the most expensive class of storage so that it's there, always ready to be searched. So if you know you need to search the data, you know you need to support a business use case where that data needs to be available, it's the best option to use. But that said, it's not cost effective for data that's unlikely to be accessed. So like if you have a compliance requirement where you need to have data searchable for a year, but you need to have that data available for 7 years for the ability to go back and look at it, but you're very unlikely to ever touch that after a year, searchable storage is not going to be a very cost-effective or practical option for that. So for data that doesn't need to be searched, the archive options are going to be better. We'll talk about those in the next few slides. But for data that you know you need to run reports on and searches, this is the best option to have. And the trade-off is, yes, it costs more, but the convenience of having that data available in Splunk and ready to be searched is definitely worth it. So Dynamic Data Active Archive, DDAA, that is your Splunk managed archive solution. So this is data that is something that can be brought back into Splunk Cloud and made searchable in Splunk Cloud and still searchable, still the normal interface, but it's something that it takes time to restore, and there's a process that you have to go through to make that data available. And I'll show you what that looks like in just a couple slides. But this is the best choice for data that you probably aren't going to need later, but you want to be able to bring it into Splunk and make it searchable if you have to. And this is data that can be thawed from the Splunk Cloud UI. You can go to an interface in Splunk, and I'll show you what this looks like. You can specify the amount of time that it takes to get that data back, or not the data back, but the range that you're looking for. So if you're looking for 6 months ago for a week period of time for a certain index, you can specify that, hit the button to let it restore that data. You wait up to 24 hours, and then that data becomes searchable. And then Splunk makes that data searchable for up to 30 days. And after 30 days, it will expire and no longer be searchable. That data is not lost or anything like that. It's just no longer searchable in the interface. If you need to restore more data to continue your investigation, you can do that as well. One of the gotchas to keep in mind is by default, and the way that this product is designed from Splunk, you can only restore up to 10% of your entitlement at one time. So if you purchase a terabyte of not searchable storage, if you purchase a terabyte of that searchable storage, you can only restore up to 100 gigs of that storage at a time. So that could be a potential issue if you have an investigation that needs to touch a large number of indexes or go through a lot of different data sources at a time. It could be a case where, hey, I only restore 100 gigs of this data, and then I need to delete that and restore data, wait another 24 hours, run my searches again, run my investigation, discover there's additional data, do that again and again, and that can take a long period of time if there's an investigation. So that is something to consider from a cost perspective and a time perspective of the effort of restoring that data, how long it might take, how might that slow down your investigations. So something that is worth at least thinking through what my solution is going to be. And like any of these archive options, the time to plan for needing to archive data is not when you're in the middle of a crisis or an investigation. You need to get the data, practice it, understand how it works, know what is involved so that you're ready to do that. Finally, our third and final storage option is dynamic data self-storage, DDSS. This is where you provision a S3 bucket in Amazon that you maintain and are responsible for. Basically, Splunk Cloud just sends that data there, and it makes it available for you to do whatever with, but it's never going to be in Splunk Cloud again. So in order to search that data, you have to actually copy those buckets from S3 down to another system, which is a local Splunk enterprise instance, and thaw that data. So it's basically analogous to if you're familiar with on-prem Splunk and thawing frozen data, it's very, very similar. The trade-off here, you're never going to be able to search that data again in Splunk Cloud because that data no longer exists in Splunk Cloud. It is totally under your control. So you need to do that. You also need to be responsible for maintaining and deploying the Splunk enterprise instance that's used to search this thawed data. So that's another thing, that having that system available, ready to use in the event you need to thaw and make data available, that's something to consider because it's not something you necessarily want to come up with a process to do when you're in the middle of needing to do an investigation. Other consideration too is that instance is going to need some disk space as well to do that thawing operation. So if you decide, you don't have that 10% limit anymore, the sky's the limit, but you still have to pay for the disk space. So if you want to restore 100 terabytes of disk or 100 terabytes from S3, you can do it. There are trade-offs for that where you have to have the associated 100 terabytes of storage to deal with that. It's going to take a long time to thaw that data, so there are some time considerations as well. You can kind of control some of that by how much CPU you allocate and resources on that as well. So this is the least expensive option because you're just paying for the S3 bucket to have that storage, but it's the least convenient option because when you need to restore it, there are manual intervention steps that you need to do as well. So with those three options, let me show you what it looks like to restore data with DDAA, which is the Splunk Active Archive approach. So if you navigate into the settings menu for indexes, you'll see the familiar options that you have for edit and deleting the index, but you also will see a link to restore when you have this option. So if you click the restore button, you're going to actually get a interface that looks like this. And from here, you can specify what date and time range you want to restore that data. This example, I just went ahead and specified a date range, and you can see it's snapped to the beginning of the day. If you need to specify a certain time, you can do that as well. You give it a name, and you can also list out emails that you'll get a notification when that data restoration is done. So that way there's no guessing about, hey, is this data complete? Can I search it, or do I have to wait? It's always a good thing to do. And that recently archived data checkbox, that usually won't be something you need to consider unless you're looking at data that would have just rolled off, like just at the end of your retention days. So if your index is set to 90 days and you're looking for 91 days ago, you might have to check that box. In this case, we're looking at something close to a year ago. We know this index retention was set a lot shorter, so this is fine. Next, you would do is click the check size button, and it's going to make sure that you have available disk space to do that restoration. That's where that 10% kind of quota comes into play. You have to make sure that Splunk has the disk space to be able to do that. I run the check here. I can see this is a really small restoration for this index, so I'm good to go ahead and restore it. I hit restore. I wait up to 24 hours for that data to be available, then get an email that says it's good. Index equals main, searching for this time frame, data is there in Splunk Cloud for the next 30 days and ready to go. So other than the whole time frame of having to identify the index that needs that data restored and the time frame for where you restore that data and then waiting for it, it's still relatively straightforward. That data is available in Splunk to use as well. Next, let's show you what it looks like to configure the self-storage option in AWS. This has a little bit more steps to do, but it still is pretty straightforward. So the way you start in this is going to be very similar to your Active Archive, where you go into your indexes settings in Splunk Cloud and hit the edit link that you can see there. In this case, I'm going to edit the main index. And if I don't have self-storage set up, which I don't in this demo, I go ahead and click the self-storage box, and it's going to tell me that there are no self-storage locations that have been created. So I don't have a dropdown to select one. If you do this in your Splunk environment, you see a dropdown, you already have that configured. But if you don't, you'll be prompted to create a self-storage location. And that takes you to the menu or the UI where you can configure self-storage locations. So you'll see dynamic data storage locations. You have a link to click to create a new self-storage location. Go ahead and do that. And then from there, you'll get this dialog where you can configure your self-storage location. And you can fill out the title, what you're going to call it. You're going to give it the descriptions, you know what it is, and then you're going to come up with your S3 bucket name. So this is two components for this S3 bucket name. It has a prefix that needs to match your Splunk Cloud stack. And you'll see this is just a demo environment, so the name is a horribly complicated thing that you never want to actually type in. But if you had your company name, it would be like, stack name, and then you would give it a bucket kind of name at the end of that. So the prefix is your stack name, and the bucket name is whatever you want to call it. That's where I came up with that DDSS demo. That's the part I came up with. Everything before that is just the stack name in this example. And then you can specify a folder in your S3 bucket. I just called it archive. And then we will click the S3 bucket policy button and generate that. And this is going to actually configure the permissions that we need for not Smart Store, but for S3 to work as expected. So we generate that, we copy it. Now we go over to AWS, We'll create a bucket. We'll make sure that that name it matches the name that we configured in Splunk already. After that bucket is created, we'll go to the permissions tab in AWS for that S3 bucket, and we will edit the bucket settings and the bucket policy. When we edit that bucket policy, we will go ahead and paste in the policy that we copied from Splunk Cloud, hit save changes. That policy will be applied. And then we will go ahead and test that with the link back in Splunk. And as long as you see the success there in the bucket policy, everything will be ready to go. And from there, you can go back. You'll see that that self-storage location is ready to go, and it is configured. From there, you go back to your indexes UI, and you go to self-storage location, and you'll be actually able to select the option. And then from there, you can select that demo archive that we created, hit save, you're ready to go. So that is all you need to worry about to get that configured. So a little bit more complicated on the upfront, but in terms of actually using it, Splunk Archive and self-storage in the UI for setting that up is going to be exactly the same in the indexes UI. You just check a different option. So let's talk about the active searchable component for Splunk Cloud. And in order to understand that, I'm going to pop up another poll and want to find out what your Splunk license looks like. So there's a couple licensing options, whether you have an ingest license, which is based on how much data you bring into Splunk per day. You might have an SVC license, which is based on how much resources you're using in Splunk. You might just not be sure, or this is not applicable. So give you a moment to collect those results and we can see what we're dealing with. As a general rule of thumb, if you've had Splunk for a really long time and haven't recently changed your contract, you probably will be an ingest license. But if you have a larger Splunk environment or are a relatively new client, a lot of times you're seeing a lot more in the SVC licensing model. There are differences with storage, but we will talk about that. Right now, I am seeing SVC is kind of winning quite a bit over the ingest license. So it means a lot of you have your larger Splunk environments where you probably have a lot going on in Splunk Cloud, and this is obviously pretty relevant to you. So to dig into the different types of licensing. So how storage works, you have ingest licensing and workload licensing. With ingest licensing, you are provisioned enough disk space for 90 days of searchable storage. And that's based on whatever your ingest license is. So if you have a 100 gig ingest license, basically you have the disk space to store 90 days times 100 gigs in Splunk math for storage in order to get that data to be searchable. You can have more disk space purchased, just like anything. Splunk will be happy to sell you more. That's something that you can get to have more space available. That said, that amount of disk space is not tied to 90 days, specifically in the sense that you cannot configure indexes to be different settings. So if you have a small index that you need to keep around for 3 years to be searchable for some compliance reason or for some convenience reason, there's nothing that says you can't configure that small index to have 3 years of searchable storage. And then you might take a larger index and only set that to be searchable for 30 days or 45 days and kind of take it as a trade-off where I'm not going to use as much disk space for this one index so that I have the opportunity to store more data in another index for a long period of time. So that's kind of how you can work around that in a way where you don't necessarily have to spend more for more disk space if you know there's maybe like one small important index that I want to keep around and you have an index license or an ingest license. So you still have a bucket of storage. How you use it is up to you, but the amount that you get included is based on what you purchase for your ingest license. Now with workload licensing, you don't get any storage included by default. And you do have to purchase storage separately in blocks, typically 500 gigs at a time, to accommodate your storage needs. The reason for this is that workload licensing is more skewed towards search consumption. So like as searches are running your environment, that's going to consume a higher amount of SVC units compared to ingesting data. And you could have a wildly different workload or ingest pattern based on how you use Splunk for the same SVC license. So you could have someone who ingests a ton of data but doesn't really search it a lot that could have a certain number of SVCs and needs a lot of backend storage in Splunk Cloud, or someone who ingests a relatively small amount of data but's running a lot of security services. They're using like our managed security services. They have a SOC. They have a lot of investigations going on. There's not a lot of disk space that's being used, but the amount of SVCs used is still equivalent to someone who's bringing a lot of data but not doing a lot with it. So hopefully that makes sense. The amount of data or disk space that you need to purchase in that case is based on how much data you're bringing in. Now, if you want to view your storage, you have the opportunity to do that through the Cloud Monitoring Console in Splunk Cloud. And you can just go to your apps drop-down, click on the Cloud Monitoring Console, and it'll display a breakdown of your licensed storage and your storage usage. In this example, we can see that this environment was allocated for 500 gigs. It's just a demo environment. And basically, I had that demo for a really short period of time. I wasn't using any data. You go to this in your environment, you'll see a different number based on what you've paid for. Also, if you have Splunk's archive, the DDAA archive, that storage number will be listed here as well. And from there, you'll be able to see how much you have available. You'll be able to see how much you've used to restore that, and just some percentages for that. Now, once this gets to the point where you're exceeding these entitlements, you'll typically see your Splunk sales rep reach out to you and give you a heads up, hey, you're going to have to make some adjustments to that, either get more storage or reduce the retention of some of your indexes in order to make sure you're hitting those marks that they have, because they do kind of watch those pretty closely these days. Now, with that all said, I want to give you a couple tips and tricks around storage and some kind of advice that I have seen. So, first, number one, for indexes, use different indexes to control your retention. So we've talked about how you might have different requirements for how you use data and make it searchable, and potentially even compliance requirements associated with data as well. So if you have different indexes, you have the ability to do a granular control of your data lifecycle, because retention settings are done on a kind of like a basis of how long that data is stored in each index. So like, as an example, if you have a compliance index, you can set that retention to a year, 3 years, 7 years, whatever you need to do. Likewise, if you have a dev index or something like that, you can set that to a much smaller window of time and control that on a granular basis. And then also, since the Cloud Monitoring Console shows you the amount of disk space that's consumed in each environment by each index, you can actually sort by disk usage. You can immediately see how much disk space is used with each index. And that way you can kind of see, oh, this index is using a lot of disk space. Maybe we need to make some adjustments to how we do that. Or is this data something that I really need to have searchable for this period of time? So having it in the individual index makes that really easy to distinguish, as opposed to trying to have to figure things out later. Something else, use a dedicated test index. Because test data is something that can consume a lot of space when you're trying to figure out how to onboard data and the best way to get something in, you can get away with a short period of retention before you get that data pushed into a production state. So that'll save some of the disk space associated with testing things. And also, because you can't easily delete data out of Splunk, if you have something where you make a horrible mistake in onboarding data and it's completely useful, that's a great one, completely useless, and it is something that you don't want to have kept around, you can actually delete the test index entirely, free up that disk space, create a new one, no harm, no issue. Whereas opposed to if you were ingesting new data into like a production index of firewall logs and you make a misconfiguration, you have a whole bunch of events that are just mashed together, that data is going to stick around in that index using up disk space for up to your retention period. There's nothing you can really do to get that back. Even if you pipe that data to the delete command, that disk space is never freed up until those buckets roll off. So keep that in mind. If you're going to, obviously, I recommend not making mistakes, but as someone who makes a lot of mistakes on their own, use a test index to its advantage in order to ensure that you have the opportunity to fix things before they're into the part where it's hard to back it out. Now, finally, ingest actions. That's something that Splunk has that can be used to significantly reduce or optimize some of the data that is being brought into Splunk Cloud. And this could be something that is used to drop unnecessary data or potentially even unnecessary fields in data. And an example, we worked with a client that had a couple common data sources. One of it was the Cisco eStreamer data, and they actually removed a lot of the fields that were in that were just blank. So you can think about, I'm sure you've seen data sources where there's fields that you never see any value other than null or zero, and it's not any data that you ever look at, but just the fact that that log name is in all the logs, it's something that's using up disk space to have stored. And actually, by just doing that for eStreamer, we saw about a 45% reduction. So almost half of the disk space associated with storing that data was just completely resolved by removing data or removing values from that data that had no value. Which to me, even working with Splunk for years, just kind of mind-blowing and crazy. The other thing is your Palo Alto Cortex logs. This was like a data lake log. We did something similar with that with ingest actions, and we're down to about 35% of storage usage. So a third of that was basically solved by just doing ingest actions, which still amazes me. But just those small optimizations, especially when we're talking about disk space, can have a massive impact in the amount of basically storage that's getting consumed. So if that sounds cool, or if any of these things are things that you might be interested in having some help with, I would be amiss to not talk about how we can do that. So if you need help with Splunk Cloud, if you need help with ingest actions, if you want advice about how to size your storage, or just interested in any other Splunk help, reach out to us. We have a bunch of different professional services offerings around working with Splunk, including ingest actions and helping you migrate to Splunk Cloud or improving your Splunk Cloud environment, helping identify searches that are using up SVCs, all kinds of different things. And last but not least, before we have questions, I want to let you know that I am going to be at Conf this year. And we'll pop up a poll. I want to see who's going to be at Conf too, and hopefully some of you will be there. If you are, stop by, say hi. I'm going to be doing a talk on Splunk administration tips and tricks. It's going to be the 6th one I've done in this series. And my colleague, Robert Pralcisco, and I are going to be doing a technical deep dive, an interactive workshop into the Splunk deployment server and sharing a lot of intimate details about how that works under the hood and things that a lot of people haven't really even seen before. So we're really excited to do that. I see already more than half of you are going to be at Conf, which is amazing. Definitely stop by. We're going to have some amazing swag at our booth. There's going to be a wheel you can spin. I think there's going to be some awesome prizes, including potentially some of our security searches through Content Plus that you could be able to win some of that. And I think they're also going to have prizes where you can meet with me for an hour for some one-on-one time to do some consulting. So all kinds of different opportunities. Say hi, mention the webinar. I don't think it'll actually accomplish any bonus, but I'll feel good or something like that. It'll be great to see you. And with that, I will open the floor for questions and help Meredith. Meredith, you'll help me triage that, and we can coordinate to get the questions all answered. So with that said, let's fire away on questions.
All right. First question up is from Trisha, and Trisha asks, does the self-storage location have to be AWS or can it be on-prem?
That is a great question. I believe the requirement is that it be S3 compatible, and I don't know if there are other cloud services that will support that S3 protocol the same way, but if you go back here to the slide where we can actually look at how that is configured, basically the bucket name, yeah, I'm actually going to say this is going to have to be AWS S3 because there's not any option to configure like a region or anything like that. So yeah, it's totally AWS. Yep. So ignore what I said. It'll be required to be S3 for that. And it doesn't look like there's any other option currently for that. So yeah, S3 only right now.
All right. Thanks, Tom. Next question up is from Suman and Suman asks, so if the S3 storage is going to be on Splunk Cloud Managed AWS Cloud or customer AWS Cloud account, if it's on the customer side, what on the firewall needs to be open?
Okay, so I'm assuming for this that we're going to be referring to the self-storage option. And that is where you provision the S3 bucket and make it available for Splunk to write to. So that's something that exists in your S3, or not S3, but your AWS account. And you are responsible for that bucket and configuring that. From a firewall perspective, you don't necessarily really have a firewall for S3. That's where that access policy comes into play. So like this access policy on the bucket policy that you configure, that's what you actually apply to AWS, and that allows Splunk Cloud to be able to talk to that bucket and write to it. So that's kind of the firewall policy for that you would make.
All right. Thank you very much, Tom. And the last question is from an anonymous attendee, and they ask, which one is better priced in the licensing?
Okay, I'm assuming this is a distinction between the SVC and ingest license options. And what I would say for that is it depends based on your use case. So kind of some of the goals around Splunk a lot of times was as you had a limitation on your usage for how much data you brought in, there was an emphasis to cut down on the amount of data that you brought in and do more with the data that you could. So we see a lot of clients that were like trying to pick and choose the data that they brought into Splunk and then do a lot of searching on that data. And that's kind of where the SVC licensing model came from, where, oh, we want to maybe lower the barrier entry to bring data into Splunk and just dictate on how you use that data. If you have a situation where you know what the amount of data that you're bringing into Splunk and you know you're going to be doing a lot with it, the ingest licensing model works better for that because you don't have to worry about how many searches you run against that data and how much you use it. If you have a situation you want to bring in more data into Splunk and don't necessarily have use cases for everything, but want to make that data available, that's kind of where the SVC model is a little bit better. But like everything in it, it's an it depends sort of thing. And I believe there's also kind of a situation where there's a break-even point. Like you have to have at least a 200 gig amount of daily ingestion before the SVC model starts making sense, just because of the overhead associated with having systems running and powering Splunk. So obviously, sales engineers can help you scope that a little bit better than I'll be able to just do by making some general recommendations. But that's kind of like the way to think about those different models. That looks like that is all of the questions.
Yes, if there are any other questions, please do not hesitate to put them in either using Q&A or just the webinar chat. We'll happily take it in either form.
Yeah, and I appreciate seeing so many people stick around all to the end. For those of you that are still here, give yourself a round of applause. Enjoy your great Wednesday. And with that said, hopefully I'll see a large number of you at Conf. If you do, stop by. If not, we will see you again for Q3 for another webinar. And I am looking forward to seeing everyone again soon. So stay in touch, reach out to us if you need help with Splunk or Splunk Cloud. And thank you all for attending. Enjoy the rest of your day and the rest of your week. Take care, everyone.